All right, in this problem, I just want to talk about a bunch of different things with a series. I may need to kind of erase and start over just for the room, but I wanted to put it all up there. So a function is given by that series, x squared, x cubed over 2 factorial, x to the fourth over 3 factorial, and so on. The general term, well, I just first of all want to fill in that this could be 1 factorial, and this could be 0 factorial. And that wouldn't change anything. So what seems to be happening is I have an x to a power, and the factorial is 1 below it. Another way you could write that is you could say it's x to the n plus 1 and n factorial. That's the general term. It's just that the x is 1 more, or the power is 1 more than the factorial. Now, estimating f prime of 1. Well, let's go back up here and say that f we think is equal to this. Okay? So estimating f prime, well, derivatives are very algebraic. If you find the derivative of one side, you should find the derivative of the other. So the derivative of x, let's just write f prime, the derivative would be approximately 1 plus 2x plus 3x squared over 2 factorial plus 4x cubed over 3 factorial plus 5x to the fourth over 4 factorial. And now we plug in 1. Okay, so if I did that, f prime of 1 would be approximately 1 plus 2 plus 3 halves plus 4 sixths plus 5 24ths, and you could calculate that. Of course, we could go more terms, but all we did was we said, well, we can just find the derivative of these terms and plug 1 in to those, since we said the function was approximated by that series. Okay, so that's easy enough. All we would need to do is find the derivative of those individual terms. Now, I'm clearing this off so I have a little room. This, of course, finding the integral, well, the first thing we'd need is the antiderivative. Since I don't know what the function is, but I do know what the series is, I should be able to find the antiderivative of the series. And I'd have 1/2 x squared plus 1/3 x cubed plus, I'm going to raise the power and divide, so I'm going to have 4 times 2 factorial there in the bottom. Here I'm going to raise the power and divide, so I'm going to have 5 times 3 factorial, and then I'm going to raise the power and divide, so 6 times 4 factorial. Now, once you find the antiderivative, we always say, well, find the antiderivative of f. I didn't know what f was, but I knew what its series, its approximate series was, so I integrated that. Now I would plug in 1 and 0. So if I plugged in 1, I'd get 1/2 plus 1/3 plus 1 over 4 times 2 is 8 plus 1 over 5 times 6 is 30 plus 1 over 6 times 24 is 144. And then you plug in 0 and you'd get 0. So this would be what you'd approximate the area with. So, it's very intuitive, I guess, in that it says find the integral, and we did. Okay, we just integrate each term. So not too bad. All right, let's keep going. So now it says find f prime of 0, f double prime of 0, and f triple prime of 0. Now, I am assuming this thing is centered around 0 because it's not x minus a to the first, or x minus a. We assume it's just x minus 0 to the first, x minus 0 squared, x minus 0 cubed, and so on. So f prime of 0, if you remember the formula for a series, the derivative, the first derivative, should line up with the first power. So we should be able to say that f prime of 0 in this case over 0 factorial is equal to the coefficient that goes with the first power. Well, here's x to the first power, so that coefficient was just 1. So f prime of 0 over 1 equals 1. That means that this is just 1. Okay, so now let's do f double prime of 0. So what we know is that f double prime of 0 over 2 factorial should be equal to the coefficient that goes with x squared, which is 1. So 1 times 2 factorial, so 1 times 2, so this is 2. Okay, and now going to last one, triple prime, we'd know that f triple prime of 0 over 3 factorial should be equal to the coefficient that goes with x cubed, which is 1/2. 1 over 2 factorial is going to be that coefficient. So 1/2 multiplied by both sides by 6, or 3 factorial, and this is 3. That's a really common multiple choice question in the AP exam. Is given a series, figure out what the derivatives must have been. And I always line them up this way, that we know the first derivative goes with, oh, I'm sorry, this should be, go back, 1 factorial. Not that it makes a difference in the calculation, but we should get that right. First derivative over 1 factorial goes with the coefficient on x to the first. The second derivative over 2 factorial goes with the coefficient on x squared, and the third derivative over 3 factorial goes with the coefficient on x cubed. Okay? Now let g of x equal f of x divided by x. So g of x is equal to every one of our terms, f of x, divided by x. So if we start doing that, we say, okay, well, x divided by x is 1. X squared divided by x is x. X cubed over 2 factorial divided by x is x squared over 2 factorial. X to the fourth over 3 factorial is x cubed over 3 factorial. So I'm just dividing every single term by x. Okay? So the general term here is that we just keep gaining an x, and it's over n factorial. Remember, there used to be a difference. Remember, our series before was x to the n plus 1 over n factorial, because the factorial was 1 higher, or I'm sorry, the power was 1 higher than the factorial, but now they're the same. So this is the first, well, I gave too many terms, we wouldn't actually need that one. So the first 4 terms of g of x and its general term. So then the last question is, well, what is g of x? Well, now you need to kind of check your memory. This is the general term for e to the x. Okay, so e to the x has that general term. So g of x must be e to the x. Well, then it goes back to, okay, well, if g of x is equal to e to the x, and that's also equal to f of x divided by x, then in the original, what is f of x? Well, doing some algebra here on our stuff down here, f of x must be equal to x times e to the x. So this is just a ton of stuff with series, finding general terms, finding the derivative of a series, finding the integral of a series, finding derivatives given the series, manipulating it by dividing each term by something, and then saying what these series actually represent. So a lot of stuff in this.